Let's go.
That's okay.
All right, so yesterday, you guys remember what we talked about? Conjunction. And what did conjunction mean in math or logic? And. And the symbol was that for and. And today we're talking about disjunction. What do you guys, anybody want to guess what disjunction means? Or. Means or. And guess what the symbol is?
Upside down.
Good guess. Okay, so what does or mean? We might have to stop and think about it. So yesterday, if I said you guys are in Algebra and you go to Wesley. Wesley, that's true, right? It's got to both be true. Yeah, but with or, I could say you guys are in Algebra or you go to public school. Okay, that would still be true because or means one of them can be true. They don't have to. And means both of them have to be true, or means just one is okay. Okay, so it's more inclusive, more inviting. And is more exclusive because both statements have to be true. Okay, now let's hook this up with some math here. So if I said, here's kind of the most normal one. What does this mean? X is less than 1. So what numbers are less than 1? Right. All the numbers to the left. So 0, -1, all those numbers. What numbers are greater than 3? All those numbers. So what numbers would work for less than 1 or, not and, or greater than 3? Is 2 less than 1 or greater than 3? No, 2 would not work. Is
anything below 1 and anything above 3.
right. It would actually be both of these. Because it's an or, they don't have to have anything in common. Yesterday when this was an and, do you guys know what the answer was when it was an and?
2.
No solution, because they don't have anything in common. No numbers are less than 1 or greater than, and greater than 3. But if you say or, like is 0 less than 1 or greater than 3? Yes. 0 is less than 1 or greater than 3. It's less than 1. So that means it's okay. So is 4 less than 1 or greater than 3? Yes, it's greater than 3. So all these numbers out here still work. So basically what this means is that or uses where either of them are at, or uses all of it. Okay? It doesn't have to have anything in common because it's an or. They don't have to share anything. Okay. That was it.
Almost Halloween. Look at it. It has something.
Okay, if I said x is greater than 1 or greater than 3, what numbers are greater than 1 or greater than 3? Okay, well, 4 would definitely be greater than 1 or greater than 3. Would 2 be greater than 1 or greater than 3? Yes, it's greater than 1. And if it applies to 1, it's okay. Or means it's okay. So basically, if either line is covering, that's going to be included in the answer. So the final answer would be all the numbers greater than 1. Okay. Yesterday when we did and, it was only where they were both at. So it would have just been greater than 3. But today, when we're doing or, if either one is covering it, it's going to be part of the answer. All right. These are kind of the key. There's 3, just like yesterday, there's 3 main examples. 1, 2. Kind of need these to do the graphs on the second section. Okay, and then the last example is the weird one. You guys remember the weird one from yesterday? Yesterday, the weird one was this with an and. What numbers are less than 1 and greater than 3? Nothing. So that was no solution yesterday. But today, this is the weird one with the or. What numbers are greater than 1? Whoops. Or less than 3?
Anything less than 3 and greater than 1?
No, that would just be the numbers from here to here. Is 4 greater than 1 or less than 3? Yes, it's greater than 1. Is 0 greater than 1 or less than 3? Yes, it's less than 3. So, and all these numbers in the middle. Is 3 greater than 1 or less than 3? Yeah, it's greater than 1. Every number, if you look at the picture, every number is covered by this one or this one. All numbers are covered. So with an or, that means every possible number is going to be part of the answer. So that on the graph, it would look like that, just a solid line. And if we're not graphing, you know what that's called? All numbers. Call it all real numbers, and this is the symbol for it. It's kind of fancy art. Or you could write the phrase all real numbers. Just means every number possible. So those are the 3 examples. If you were taking notes, that would have been what you should have written down. You're probably going to miss that. I don't think, let's see if they booked it. Kind of. Yeah. Examples 1, 2, and 4 basically ish like that. Okay. Number 1. You guys ready? Jump in here. In a conjunction, inequality statements are joined by the word what?
4.
No, conjunction was yesterday. So, yeah, conjunction is and. Okay. 3 and 4, we did not talk about these 2 words. I don't really care about these 2 words, but we'll go ahead and write it down so we don't leave any blanks in here. The solution to a disjunction is the blank of the 2 sets. That's called a union of the 2 sets. And on 4, the, what's it say? The solution to a conjunction, that's called the intersection. I don't really care about those 2, but that's okay. We'll just write them down and move on. Maybe you'll see them again someday in your life, but not in this class. Okay, number 5. The blank symbol kind of looks like a V, indicates a what?
4.
Yeah, this symbol, well, it's an or, but what's the or go with? No, disjunction. I scrolled all the way up there for that. Disjunction. So 6 is the other symbol, so it's the other one. Anyway, 7, graph. It's you guys' favorite part. Less than 2 or greater than 5. So we need to have at least 2 and 5 on the graph. So what would less than 2 by itself look like? All these numbers left. What's greater than 5 look like? All these numbers to the right. Okay, what numbers are less than 2 or greater than 5? You guys remember what this one turns into? It'll make me scroll. Right here. Because it's an or, it doesn't matter that they don't have anything in common. Both of them are still used. This is my first example. So it just, basically the answer looks exactly like the floating lines. So it'd be all the numbers less than 2 and all the numbers greater than 5. Number 9, x is greater than 2 or x is greater than 5. Okay, so 2, 3, 4, 5. X is greater than 2, all those numbers. X is greater than 5, all those numbers. So what numbers are greater than 2 or greater than 5? Would the number, well, 6 over here, 6 would definitely be greater than 2 or greater than 5, right? Both. But is the number 3 greater than 2 or greater than 5?
No.
Yes.
Oh, yeah,
Because it's greater than 2, because it's or. Different than yesterday. Yesterday was an and. So it is greater than 2, so 3 would work. Would 2 work? Is 2 greater than 2 or greater than 5? No, 2 is not greater than 2. So 2 would work. So basically all these numbers, if it's covered by one of the lines, it's going to be part of the answer. So all these numbers back here going forward are part of the answer.
There's 2 a lot.
They're repeating the numbers on the first 4, 2 and 5. 11, x is less than -4 or x is greater than -4. Okay, so on this one, they only give us one number. -4. So x is less than -4 would be all the numbers less than -4, or x is greater than -4, all these numbers. So what numbers would be included in the answer? What numbers are less than -4 or greater than -4? All of them except for, yeah, -4, because see how there's a hole right here on both of them? So -4 would not be included in either of these.
If it was,
But every other number is covered.
if it was, greater than or equal to, would 4 be included?
Yes, if it's greater than or equal to on one of these, that would include every number, so it would be like all real numbers, the solid line. But -4 is not included. All right, 13 is not graphing, but to explain it, I am going to draw a graph. So 13 just says what numbers are not equal to 6 or not equal to 3. Yeah. Not equal to 6 or not equal to 3. Okay, what would that include? You guys remember the graph for not equals to? Not equals to 3 looks like this. Everything but 3. Not equals to 6 looks like that. Everything but 6. So what numbers would be included if we're talking about numbers not equal to 3 or not equal to 6? What numbers are covered by these two lines together? All numbers. All numbers are covered. On this line, 3 is not covered, like x is not equal to 3. 3 is not covered. But on this line, 3 is covered. On this line, 6 is not covered, but on this line, 6 is covered. So every number possible is covered. So you would include everything. So the answer is, it's not the graph. We're not graphing on these, but all real numbers.
Can we do the graph if it's easier?
No, the answer is going to be like,
Well, yeah, but like to show.
if you look at the rest of them, like 13 through 20, you're solving inequalities, remember yesterday? So it's not really a graphing thing, but to simplify it, a graph can help. But I am not going to make you guys simplify the evens. Probably not worth the struggle. Not simplify completely. But just like yesterday, greater than 10. Okay, who needs picked on? Wyatt. What would I do to solve this one right here? Can't remember who I called on yesterday. Add 6. Okay, a lot of people freak out when they get a 0. Don't freak out. 0 is an acceptable answer. It's okay. So just be wise, less than or equal to 0. Okay, what would I do on the other side? Add 5. And then divide 3. So we get y is greater than 5. Okay, now if this was an even, this is where you guys could stop right there. But just like yesterday, if it's an odd, let's try to simplify it. What numbers are less than or equal to 0 or greater than 5? Well, remember like a number 7, if they're going opposite directions like this, all of these numbers would just be included. All the numbers less than 0, all the numbers greater than 5. So really the answer doesn't simplify on this one, it just stays the same. Because it's an or, they can coexist. It's okay. Number 17. Let's see, Triton on the right side on 17. What would we do first before I write all that down? You see where I'm looking? Well, tell me first, don't write first. What can we do on the right side on 17?
You would add 8b to 2b.
Right. So instead of writing all that down, we'll just put 10b minus 3. And then what was after that? I lost my place. Minus 3 is greater than 27. Okay.
You minus them twice.
Whoops. All right. Try. What would I do on this left one?
You would plus 6.
And then
You would divide 2b.
divide the 2. So it's b is greater than or equal to 10. And what would I do on this side?
You would you plus the 3.
Add 3 is 10. B is greater than 30. And then
You would divide 10 too.
divide 10. Not the b, just the 10. So it's b is greater than 3. Okay. So if this wasn't even, you could stop here, but this one actually does simplify some. What numbers are greater than or equal to 10 or greater than 3?
4, 5, 6.
Yep, but how do we write that simply? He said 4, 5, 6. That's all the numbers bigger than 3, right? So the simplified answer would just be this part.
Greater than 3.
B is greater than 3. Alright, we're already at the end. See, that wasn't so bad. Not too painful. 3x plus 6 less or equal to -9. Or x is less than, well, they were nice to us on 19 for some reason. Because x is less than 9 does not need solved. It's already good to go. So, Katie, what should I do on this side?
-6.
Okay, that would be -15. Now what should I do?
The 5's 20.
Okay, yeah. Not switching the inequality because I'm not dividing by a negative. I'm dividing by +3. Okay, does this simplify? What numbers are less than or equal to 5 or less than 9? -5. Less than or equal to -5, smaller than -5, or less than 9. What numbers would that include? Would that include 8?
What number's less than 9?
Yes, it would. It would include all these numbers that are covered. So that would be x is less than 9. The simplifying part is kind of the hard part. That's why I'm not making you guys do it. But when you get in Algebra 2, I'll probably make you guys do that part. But you guys will be older and wiser by then, right? My Algebra 2 class says, no, we can't do it. I remember this. And then they try it and they're like, oh, we can do it. You do actually get smarter. It happens. What's that, Allison? You got a comment?